Imagine stepping back in time to the golden age of aviation. You are sitting in the cockpit of the legendary Douglas DC-3, known to us as the Flabob Express. Today, we aren't just reading a training manual. We are embarking on a journey to understand how this massive bird actually flies. This is Chapter 1, Flight Controls. For a pilot, these controls are the nervous system of the aircraft, translating every thought into physical movement. It is a system built on reliability, mechanical honesty, and a direct connection between the pilot and the machine. Unlike modern jets controlled by computers, the DC-3 requires a tactile understanding of its mechanical heart. So, let's take hold of the controls and see what makes this classic airplane tick. We will explore how steel cables and physical leverage allow a human to master the skies in one of the most successful transport aircraft ever built. The DC-3 uses a system that is beautifully simple yet incredibly robust, a cable-operated dual-control system. Think of it like a giant marionette. There are no complex computers or fly-by-wire circuits here. Instead, we have high-strength steel cables running from the cockpit all the way to the tail and wings. Every movement the pilot makes is transmitted directly to the flight surfaces. We have complete dual controls, meaning the pilot and co-pilot each have their own control column and rudder pedals working in perfect harmony. To make the pilot's life easier, the primary surfaces are aerodynamically balanced to lighten the physical load of moving them through the air. And to ensure safety, we use static counterweights, specifically an 8-pound weight in each elevator, to prevent the dangerous vibration we call flutter. The construction itself uses metal frames covered in fabric for the primary surfaces, while the trim tabs are all metal for durability. Now, let's look at how these primary controls actually move the aircraft through the sky. For the elevators, it's a simple fore and aft motion on the control column to pitch the nose up or down. If you want to roll or turn, you rotate the control wheel, which moves the ailerons via a series of chains, cables, and bell cranks. And for the rudder, that's all in the feet, using the rudder pedals to control your yaw. What makes the DC-3 special is how interconnected everything is. The two control columns are joined by a sturdy torque tube. This means when the pilot moves their wheel, the co-pilot's wheel moves in unison. It's a shared experience in the cockpit. We also have adjustable stops and bumpers to ensure the controls stay within their safe limits, preventing any overextension during flight maneuvers. This mechanical linkage ensures that even if one pilot is incapacitated, the other maintains full control of the aircraft's trajectory. Moving our gaze to the center, we find the control pedestal. This is the command center where the pilot manages the aircraft's power and balance. At the top, you'll find the engine controls, the levers for propeller pitch, throttle, fuel mixture, and carburetor air. Below those are the vital fuel tank selectors for both the right and left engines. But it's not just about power. The lower half of the pedestal houses the trim controls and locking mechanisms. You'll see the cranks for the aileron and rudder trim and the prominent wheel for the elevator trim. There's also the parking brake control and the tail wheel lock, which are essential for stable ground operations and takeoffs. It's a dense array of controls, but each one is positioned ergonomically to be within easy reach. Mastery of this pedestal is what separates a student from a professional DC-3 captain, requiring a gentle touch and constant monitoring of the various indicators. Flying a plane as large as the DC-3 can be physically demanding, which is why the 3 trim tabs are a pilot's best friend. These small surfaces allow us to fine-tune the aircraft's attitude so it flies level without constant effort. The elevator trim wheel is on the left of the pedestal. Moving it forward corrects a tail-heavy condition, while moving it aft helps with a nose-heavy plane. For the rudder, a crank on the lower left corrects for any unwanted yaw or pull. Finally, the aileron trim, controlled by a crank on the lower right, adjusts for wing heaviness. Interestingly, the aileron trim on this aircraft only affects the right aileron. A key rule for every pilot: always check your graduated dials and set your trim properly before takeoff. You must also recheck them after any configuration changes, like lowering the flaps or landing gear, to ensure the aircraft remains stable and easy to handle. Let's talk about how this is all built and maintained. The primary surfaces, the ailerons, elevators, and rudder are constructed with metal frames but covered in fabric. This classic design keeps the surfaces light and responsive. Because there is no hydraulic boost in this airplane, we rely entirely on aerodynamic balance to keep control forces manageable by hand. As we mentioned, static balance is just as important. Those 8-pound counterweights in the elevators guard against control flutter, which could otherwise tear the plane apart at high speeds. The entire system is linked by steel cables, elbows, and bell cranks that transmit every input. This brings us to a vital point: rigging matters. During every pre-flight check, a professional pilot ensures that the cable tension is correct and that every surface has full, free, and correct travel. If the rigging is off, the plane won't fly true, and the pilot will have to work much harder to maintain a steady course. To wrap up our look at the DC-3's flight controls, let's review the key points we've covered today. Remember, it's a dual control set joined by a torque tube powered by mechanical cable actuation rather than hydraulics. We have those critical 8-pound counterweights in the elevators and a trim system that is as manual as it is effective. You've got the elevator wheel on the left, the rudder crank on the lower left, and the aileron trim on the lower right. Mastering these mechanical connections and understanding how they interact with the air is the first step in becoming a true DC-3 pilot. This aircraft speaks to you through the controls, and learning to listen to that feedback is the hallmark of a professional. Thank you for your attention during this first chapter of the Flabob Express Training Manual. Next up, we will be moving on to Deck 07 to discuss the power plants and engine systems.